Kali Linux has over 600 tools. The hard part isn't running them, the hard part is deciding what to run next. And today I'm going to remove that friction, at least I will try, and let AI orchestrate the workflow. One sentence, full assessment, and live. And behind the scene I have HexStrike as an AI orchestrator. So everything you are about to see runs against my local host on my own lab system, and never test systems without explicit written and authorization. Okay, that's important. We are not promoting illegal activities here. So let me show you what's actually happening behind the scene. So Claude Desktop is running on my host machine. That will be my reasoning layer. Inside the virtual box of Oracle, I'm running a Kali Linux VM, and that's where my HexStrike is installed and running as an MCP backend server. And the HexStrike runs locally inside the Kali and exposes security tools through the MCP. Now, one line about MCP, if you are not familiar with that, it's a model context protocol, which is a standard that allows AI models to call external tools as structured, executable functions. So in Claude Desktop, I configured an MCP connection that points to the HexStrike server that is inside my Kali VM. So Claude sends structured requests to the backend server, and Kali execute the actual tools. Easy. Remember, Claude cannot run Nmap, for example, on its own. It can reason, but it cannot execute. The MCP bridge connects reasoning to execution. So Claude handles reasoning and Kali handles execution. Okay, now everything is an open source. The full project is available on GitHub, including the backend server and MCP interface. It has a great installation documentation in the README file, so you can clone the repository, start the backend, and typically with the Docker and the MCP server becomes available. So no hidden components, no black box agent, relatively simple. If you still have problems, leave your comment in the description and I will help you. So here is the actual configuration inside Claude Desktop. I registered a custom MCP server pointing to the HexStrike backend running in Kali. That means when I tell Claude to use HexStrike, it calls my local VM, not some external service. All tool execution happens locally inside the VM. Okay, now before I'm running a scan, let's validate the integration, and here I'm using a basic prompt, use HexStrike, and it will provide me all of the list of available tools. These aren't a description of tools, these are callable function exposed by the MCP server. Claude can now invoke them with structured parameters, and we can see the bridge is working, and we can run the assessment from networking to web to cloud, vulnerabilities, even to capture the flag, and many other AI powerful tools, more than 100. In order to do that, I use the HexStrike AI to scan my local host and identify exposed services, and I ask him also to summarize the risk, and that's it. So notice what it's doing. It's launching a full Nmap scan, version detection enable. It's not stopping at open ports, it's executing actually additional scripts for vulnerability enumeration, and it detected some services like SSH on 22, Apache on 80, and Python dev server, and it automatically triggers more and more scanning, more over 5,000 vulnerability templates and CVEs and misconfiguration and exploit pattern. This is orchestration, it's not just automation. And here is the key difference. It's not dumping raw output. You can see that it's maintaining context. So it highlights each item, where are your vulnerabilities, what did he found, what are the high risks and its recommendations, what are the priorities, and everything is sorted. So traditionally, that workflow requires multiple terminals, manual correlation, CVE research, report drafting. This happens in under 3 minutes from one sentence. So few words about HexStrike AI, which is an open source cybersecurity orchestration platform. It exposes more than 100 tools through MCP, the model context protocol. That means that AI models can call security tools as structured functions. It doesn't describe them, it executes them. Installation takes about few minutes, very easy, follow the README file in the GitHub project. And the architecture is built based on 4 layers, I can say. So layer 1 is the model. I'm using Claude. You can use your local LLM or ChatGPT, etc. This handles the reasoning and planning. The layer 2 is the MCP bridge. So HexStrike exposes tool functions with structured parameters. Layer 3 is the execution layer. These are the Kali tools run. Output returns structure. And layer 4 is the evidence logging. Everything timestamp for defensibility. Now here is the professional question. Where does your data go? Now in this demo I use Claude, which is a cloud model. This means my reconnaissance data probably leaves my machine. Now for localhost testing it's acceptable maybe, but for regulated environment, private data, this is under compliance issue. So if you are sending government or healthcare reconnaissance data into a public LLM, you don't have a tool problem, you have a compliance problem. Remember that. Now, HexStrike also works with local models like Olama, fully air-gapped, no external data transfer. And what's the trade-off? Weaker reasoning, so more tuning that is required. So choose based on compliance requirements, not demo and performance. Now, I touched before a bit about the workflow, and traditional workflow is a tool-centric, right? Run Nmap, read output, identify findings, research CVs, launch next tool, copy result, build mental model, write report, which is important. And here, the AI-assisted workflow is context-centric. So it shows a clean flow. One request, remember that I have to scan my local host and come back with the report. So multi-tool orchestration, automatic CV correlation, prioritization remediation, and evidence logging. And the AI doesn't make tools smarter, it makes the workflows coherent. So you stay focused on reasoning, not terminal management, and that's key. So where does this actually fit in real offensive security, you may ask? So first, this is not Kali replacement software. It runs on Kali, it runs on Parrot, it runs anywhere actually. You can host the backend server. Now, if you prefer Parrot OS, Debian-based lab setups, or even custom hardened environments, the backend just needs a Linux execution layer. The real shift isn't just the operating system, it's the orchestration layer. Instead of thinking in individual tools, like Nmap and others, you start thinking in attack narratives. So traditional pen testing is based on tools. AI-assisted testing becomes hypothesis-driven. What does it mean? You give it an intent, it sequences tools dynamically, rather than manually that we are doing in the traditional pen testing way. And here is something important. The architecture is model agnostic. So today I'm using Claude, tomorrow you can swap it with the GPT, or you can run a local LLM, you could air-gap it entirely. The orchestration layer stays the same. Now, this doesn't remove the need for skills. It removes friction between skill and execution. And that's much stronger than AI is probability engine, right? Now, HexStrike AI is real, it works, at least from what I played with. It will not make you a pen tester, but if you already have some fundamentals, this is a force multiplier. The upgrade isn't that it runs tools for you, the upgrade is that it maintains workflow context across tools. So please use it responsibly. This is the beginning of AI-assisted offensive security. I will leave the link in the description. Try it on your local host, understand the guidelines, and if you want part 2, which is a full recon to report workflow using AI orchestration only, comment in the description. Stay sharp, stay ethical, and most importantly, stay legal. See you in the next video.